Hello! In this video I will show you how I scanned different models using this 3D scanner, how I processed these scans, how I got them into Blender for sculpting, rigging and rendering, and I will talk about my experiences with this type of scanner. My name is Chris and this is the Revopoint POP3. I have scanned fake plants, real plants, skulls, stuffed animals, squashes, hands, decorations, electronic devices, toys, collectibles and more. I'm still new to 3D scanning, but I think I already have a pretty good understanding of what's great, what's possible and what's difficult. And in this video I will share what I have learned that you might want to know before buying a 3D scanner. Revopoint sent me this scanner for free, however I'm not paid by them and I'm free to tell you my honest opinions. Let's first see what's in the box. Everything comes in this nice carrying case. We got a little tripod that's also extendable, a mini turntable powered by USB with adjustable direction and speed, a sample model bust, the 3D scanner itself, and on the other side the iPhone holder, USB cables and adapters, a calibration board, different types of markers and a quick start guide. I will not bore you with technical specs, you can find everything on the Revopoint homepage. Note that there are different 3D scanner models available from Revopoint, which mainly differ by the size of objects you can scan. The POP3 is for medium-sized objects. Of course, after unpacking and connecting everything, you download the Revo Scan software and give it a go by scanning the included bust, which has an easy-to-scan surface. I will talk more about scanning different types of surfaces later. You can scan directly to your desktop computer, either Windows or Mac, but this is also a very nice mobile solution, since you can scan directly to your Android or iPhone device. You connect your device using the provided USB cables, or wirelessly by connecting your Wi-Fi to the POP3 scanner. I tested the Revo Scan on Windows and on Android. The apps look and feel very similar, with the desktop version providing all the bells and whistles, but even the mobile version has the ability to post-process the scans, or you can send the raw scan data to your desktop app for further processing. The apps worked beautifully without crashes. Scanning is straightforward, but I quickly realized that you do need some practice. The scanner needs to be at the right distance from the model at all times. You need to move slowly with a steady hand and smooth motions and point the scanner at the model from all different directions. You need to do this to avoid faulty frames, which can result in glitches and artifacts in the scan result. At first I worried way too much about the lighting setup, but the scanner has integrated flashing LEDs for the color camera and the lighting in the room should just be as soft and uniform as possible to avoid highlights and shadows. And in my experience you don't need bright lighting. In fact, I got better results with darker room lights. Maybe the infrared 3D cameras work better that way. Since we're at it, the scanner uses structured infrared light to get a depth reading on each frame. It captures around 15 frames per second, plus minus. And depending on the size of your model, you will usually end up with several thousand frames in a successful scan. The software then creates a point cloud out of all those frames and it shows a preview in real time on screen while you are scanning. If you decide to do a color scan, the camera built into the POP3 adds color information to each point in the point cloud. Both the 3D camera and the color camera have adjustable exposure settings, and for the color camera you can also adjust the color temperature. The scanner has 3 buttons on the back to start and pause scans and to manually adjust the exposure of the 3D camera. Since the scanner just captures frames and sends them to your computer or smartphone, the Revo Scan software running there must figure out how all these frames fit together in 3D space. It does that either by detecting and matching the 3D features of the model or by tracking markers. Organic shapes can easily be scanned with feature tracking, but if your model has a more uniform shape, you will need to stick marker dots on it and use marker tracking. I think a really good example to explain this is this wooden art mannequin. Moved into this A pose, the scanner cannot easily tell the difference if it's facing the left or the right side of the model, especially since the scan area at the correct scanning distance is only a part of the mannequin. After I moved it into a more random, organic pose, the scan with feature tracking worked just fine, since there are always some hints available to the software here in the arms and the legs as to which side I'm currently scanning. This globe, however, seems impossible to scan with feature tracking since it's shape looks exactly the same from all angles. Remember, feature tracking doesn't include the information from the color camera, only the 3D features, and in this case that's a simple sphere. With a little trick, we can however still get a color scan of the globe. Just place some random objects that do have distinct organic 3D features around it to help the app successfully track the location of the scanner. This same trick can be used in other situations as well. Here I wanted to just get the measurements of the inside perimeter of this plastic tray. And to help the location tracking algorithm, I again placed some objects into the tray for scanning. Marker tracking has the obvious disadvantage that you have to place marker dots onto the objects, which is not only time consuming, but they are of course visible in color scans. Let's take this vintage wooden butter mold for example. Even though the surface is matte wood and perfect for scanning, and yes, the inside with the carvings actually scans beautifully, the outside surfaces are just uniform flat planes. And the feature tracking can't know which side the scanner is currently looking at. With a bunch of markers stuck to the wood, I was able to get a usable scan. I brought the model into Blender and then used the clone tool in texture painting mode to paint out the markers. The sticky markers are a good solution for parts where you're only interested in the 3D shape, not the color. For example, metal car body parts for reverse engineering and repair purposes. Another way of using marker tracking is to have the object sit on either the marker topper, for example on the turntable, or the so-called magic mat for slightly larger objects. As long as the software can see enough markers on each frame, it can determine the location of the scanner and merge the scanned data into the 3D point cloud. For my use cases and what I would use a 3D scanner for, I gotta say I'm not a fan of the stick-on markers. Let's talk about surfaces now. The magic of the 3D scanner is based on infrared light. Therefore, it is basically impossible to scan transparent surfaces without first making them opaque somehow. Same goes for reflective, shiny, glossy surfaces. The infrared light simply gets reflected away and the 3D scanner can't get a good reading. How could you make these surfaces opaque? One destructive way would be to spray paint everything with a bright matte color. But there are also special scanning sprays available that can be washed or wiped off. There are even scanning sprays that dissolve after a few hours. Those are quite pricey though. And you really need to make sure you can spray these sorts of chemicals onto the objects without damaging them. You could also put some masking tape over transparent or shiny surfaces, but whatever you do to the model to make it 3D scannable, you will not be able to get accurate color scans. And then there are black or very dark surfaces that simply absorb the infrared light, just like all the other light frequencies. There is a special dark object mode you can select in Revo Scan, but that seems to only help a little bit, and also only for objects that are dark all over. Objects with normal colors and black parts are tricky. Let's take this Playmobil Cleopatra for example. The plastic surfaces are rather shiny, almost too shiny for a clean scan. The black hair and eye makeup, however, disappear completely. So we would have to recreate those in Blender or add a really wild hair simulation. This Zoom audio recorder is mostly black, and the parts that are not black are shiny and reflective. This, I would say, is virtually impossible to scan. Alright, there are several things that are hard to scan with an infrared-based 3D scanner. So what are good surfaces to scan in color and using feature tracking? Basically everything that is not too dark and has a matte, even surface. Raw wood, for example, like the mannequin you already saw or these decorations. This collectible Schleich ice bear also has the perfect surface, except for the black nose. Possibly the best scan so far was this skull of a stag or sheep or whatever that once was. Here's a Blender Cycles render of the textured mesh as well as the point cloud I got from Revo Scan. I actually really like the point cloud look. Now let's take a quick look at the entire process from scanning to processing the point cloud and importing in Blender. First, we hook up the scanner, start Revo Scan, start a new project and select the settings matching the object we want to scan. For example, feature tracking, color scanning, and I usually reduce the scanning distance to max out around 30 centimeters. We start the turntable and start scanning. First around the middle, then move up to the top, looking down, as good as we can get it. We can pause the scan, lay the model on its side and continue scanning. Here it is best to resume when the scanner faces a part of the model we had already scanned before. That's for the feature tracking algorithm to work properly. The scanning step takes a few minutes. When we have all the details, we click Complete, and that gives us the raw point cloud. The only thing we can do at this point is go into the keyframe editor, where we can delete individual frames from the scan data. This is actually really useful because sometimes we get a few glitched out frames, maybe from reflections or a jerky movement. We just kick those frames out and only keep the good ones before we continue. We can now start processing the data, and the first step necessary is fusion. I always just pick the smallest point distance here. This step takes some time, depending on the amount of frames we scanned, and results in a point cloud that we can now edit and process further. This video is not intended to be a comprehensive guide to Revo Scan, so here is just a quick overview. You step through the features shown in the main menu bar from left to right. When fusion is done, the point cloud editing options become available. The automatic features are in the main menu bar. Each feature has settings and options for you to adjust, and Revo Scan also shows handy instructions underneath. You can also manually select and delete unwanted points using the tools from the toolbar on the right. Info about the current scan, point cloud and mesh can be found in the properties panel in the bottom left corner. When you're done editing the point cloud, you can create a mesh, and the mesh editing features become available. Again, you have automated tools on top and manual tools on the side. The last step is to texture the model, and then you can export the point cloud, the untextured mesh, and the textured mesh. A quick note about the merge feature. This lets you merge multiple scans into a single object. You can do this with point clouds after the fusion process and with meshes. The merge algorithm automatically detects how the scanned models fit together based on the 3D shape, which means you need to overlap characteristic features during scanning. If anybody from the Revo Scan software development team is watching, it would sometimes be really nice to be able to cancel the fusion process. Right now I have to wait for it to finish, even if I realize that the scan has issues like maybe I forgot to clean out some messy frames. With the point cloud exported to a PLY file and the textured mesh exported to an OBJ file, it is now time to jump into Blender and see what we got. Let's first import the point cloud from the PLY file. In the import dialog, you need to set the scale value to 0.001. That's just the usual issue with scales and units and moving between different apps. Using 0.001, you get real-world dimensions. We see all the points in the 3D viewport, but nothing shows up in the rendered view. That's because these are just infinitely small points in 3D space, and there is nothing to render. How can we make these points visible? One way is to instance, for example, an icosphere onto each point. That way we get real mesh that both Eevee and Cycles can render. If you're targeting Cycles, however, we can also take advantage of a Cycles-specific feature. Cycles can render point clouds directly. Here in geometry nodes, we can see that in Blender's world, these points are just vertices and therefore technically still a mesh, not a Blender point cloud. But we can convert the mesh to points, and now Cycles renders actual spheres for each point, taking the radius of the points into account. Now, how do we color these points? The PLY file with the point cloud from Revo Scan includes a vertex color slot. So all we have to do is use the color attribute called col from the geometry in the shader and assign that material inside of geometry nodes. We can also use the mesh from Revo Scan by importing the OBJ file, again using the scale value of 0.001. And with a single click, we get the mesh and the material with the texture map already applied using the UV map Revo Scan had also generated for us. Nice! With the mesh in Blender, we can now, for example, use modifiers like decimate if the model still has too much geometry, or remesh to quickly get quad-based topology, add details in sculpt mode, like the nose of this ice bear that didn't get scanned because it was black, or texture paint directly onto the 3D model. Here I added an armature and used Rigify to get a rig with inverse kinematics for easy posing and animation purposes. And here I 3D printed a few squashes from this year's Thanksgiving decorations, which were then primed and painted to be displayed next year. Now here are my final thoughts on the Revopoint POP3 and the Revo Scan app. The biggest issues when scanning come from the different surface types and colors. Plastics can be just a bit too shiny, and most objects like collectibles have some parts or pieces that are black. This reduces the overall possible use cases, which is a pity. My advice here: think about your planned use cases and these limitations before you make a purchase decision. Again, you can use scanning spray, but that adds to the workload and cost, and I'm sure you can't just spray that stuff onto anything. These limitations are not that different from photogrammetry, which I have done in the past too, where transmissive and reflective surfaces are also problematic. Compared to photogrammetry, using a scanner like the POP3 is much easier and faster. I wish the feature tracking algorithm would take the color information into account somehow, so that uniform shapes can be scanned more easily in color and without markers. What you get out of the box is a very nice and complete set with all the cables and even a tripod and phone holder for mobile scans. Quick side note, the phone holder is not big enough for my S23 Ultra with the case on. And without the case, it just barely fits. But it fits. The fact that you can scan to a mobile phone is awesome for when you need to scan on the go, maybe at a client's or friend's location. You already have a really powerful computer in your pocket that, in combination with a tool like the POP3, can be utilized for 3D scanning. So if you're not scanning professionally all day, every day, a combination like this can be the more sensible and affordable solution compared to an all-in-one device like the Revopoint Miracle, for example. The set includes a special USB cable that plugs into your phone and into a USB power bank you need to bring along. That's fine, except that the cable for the power input is so short that you have to hold the power bank in the air along with the scanner. You will want to get a USB extension cord so you can put the power bank in a pocket. The small turntable is a great tool to have included in the box, and now that I have scanned so many things with it, I can see why you won't want the special dual-axis turntable from Revopoint that you can control from the app and even control the tilt to easily scan from multiple angles. I simply love the fact that with a 3D scanner like the Revopoint POP3, it is possible to quickly bring complex objects from the real world into the virtual world with high accuracy and precise scale. And with mesh editing tools like Blender provides, the possibilities to further edit and optimize these models are limitless. Preservation of historic objects, game asset creation, reverse engineering, reproduction, and so on and so forth. I will definitely scan more objects in the future and share tips, results, and inspiration on my social channels. Please take a second to like this video and subscribe for more videos. Let me know what you think of this kind of practical tech review video, and if you would like to see more videos like this in the future, and which gadgets I should try out. If you have questions, just ask in the comment section and I will do my best to answer ASAP. Finally, for everyone who made it all the way to the end of this video, if you now decide to give it a shot and plan to purchase any of the Revopoint scanners, please use my affiliate links from the show notes below. This adds absolutely no extra cost to you, but I get a little commission for my efforts. Thank you. I was also able to get a discount code for you. You can find the details in the video description and save some money. Thanks again to Revopoint for sending me the POP3, and thank you for watching. See you soon.